Hey everyone, so this is day 2 of inverses of functions. So start by pausing the video and doing the do now. So we're going to do f of g, okay, so this one, f is the outside, so f of g of x equals, so 2 something minus 8, and then the inside is g of x over 2 plus 8. So if I simplify that, I get x plus 16 minus 8, which is x plus 8. Then we'll do the other one. This time g is on the outside. So g is something over 2 plus 8. That thing that's over 2 is 2x minus 8. If I simplify that, I get x minus 4 plus 8, x plus 4. So now, are those two inverses? They are not. When you do the composition of inverses, you get x. So these look like they could be, but they're not. I think if you made that one a 4, yeah, if you make that the 8.8 and g of x a 4, it would have worked. But so those are not inverses. Okay, so I touched on this last time. What does it mean for a function to be 1-to-1? Every f of a function maps to exactly 1y, and every y maps to exactly 1x. So I like to use the example when we talk about functions of dating. Like, girls cannot cheat on their y boyfriends. Well, with 1-to-1, it's the same, it's backwards also. So think of monogamy. Every x to 1y, every y to 1x. So if we have 1, 2, 3, 2, that is a function, but not 1-to-1. Okay. Since I have space on here, another thing I want to talk about, I skipped this and I regretted it after I looked at the video I made the other day, and that's some notation. So what is the inverse notation? So we're going to add that in. What is inverse notation? So if you have a function f of x, its inverse is written f minus 1 of x. Now be careful, because that minus 1 does not mean 1 over f of x. That's different. A little minus 1 like this represents an inverse function. And it is confusing because sometimes you see the minus 1 and it means inverse. Sometimes you see the minus 1 and it means 1 over. So think back to geometry. Remember in geometry when you did like sine minus 1 of x? Or sine minus 1 of something? That was your inverse. It was the inverse of sine was sine minus 1, and that's why it was like that, because the minus 1 means the inverse function. Right? So you will see f minus 1. So in the homework the other day, it was like f, and then its inverse was g, but you could do f and f minus 1. Okay, so are the following functions 1-to-1? So first you have to say that it's a function. So think about what number 1 looks like. That is a graph, right? It is a function and it is 1-to-1. So yes, 1-to-1. Every x goes to 1y, every y to 1x. How about number 2? What does that graph look like? That's a parabola. I have no idea about the parabola, but I know it's a parabola. Now, is this 1-to-1? This is not, because let's say that is the number 4, the y value 4. There are 2 x values that will hit that. So this is not 1-to-1. So it is a function, but is not 1-to-1. Number 3, what is that a graph of? That is a absolute value. And again, absolute values are not. If you take a y value, there's multiple x values that will hit it, right? Negative 10, 5, 2, 5, or whatever it is. And then the last one, the square root. A square root looks like that. And that is 1 to 1. 1 to 1. Not 1 to 1. So every x gives you 1y, every y gives you 1x. So for a 1-to-1, for a function to be 1-to-1, it must pass the horizontal line test. So a good way to check is if you can draw a horizontal line and it only hits the graph once, it is 1-to-1. So this is 1-to-1. B, they drew it for you. This is not 1-to-1. It hits twice. C, if I draw a horizontal line, hits the graph twice, so that's not 1-to-1. And then this is actually the sine curve. You'll learn about this in pre-calc next year, or trig. That is also not 1-to-1. So letter A is the only one that is 1-to-1. Well, I guess it's a multiple choice question, so. If a function is not 1-to-1, we must restrict the domain in order to find the inverse. So here's the example that I talk about a lot. If you have a parabola, x squared, y equals x squared, and you have a square root of x. We say that when we do the composition, actually, you know what, let's change this to f and g. F of x and then g of x. So I kind of keep mentioning this because it's important in calculus. If you do f of g of x, it's not, you get x squared, the square root of x squared. No, I just did that backwards, didn't I? Yep. It's, okay, I can do this, guys. I can do it. Something squared, the square root. And I kind of was making a big deal. This does not equal x. It equals the absolute value of x because these are not technically inverses. And it has to do with the domain. Because f of x, x squared, is not 1-to-1. So what we have to do is say, okay, instead of having f of x all real numbers, I'm just going to take off part of it. I'm going to say the domain of this is 0 to infinity, or x is greater than or equal to 0. Now, those are inverses, and it does work. All right, so restrict the domain of the function and then find its inverse. So basically what we're going to do is think about the graph. So I'm going to restrict my domain to what? What do I want my x to be greater than? So basically, we're just going to cut off half of it. So I'm going to say x has to be greater than or equal to 0. Or we can say it's 0 to infinity, either way. So now we're going to find the inverse. So remember, we do x equals y squared minus 8. X plus 8 equals equals y squared. So y equals the square root of x plus 8. So we have f minus 1 of x equals the square root of x plus 8. Because if x is greater, if the domain of this one is greater than 0, the range is -8 to infinity, right? 0 to infinity, -8 to infinity. So what would the domain of this one be? Your domain, this has to be -8 to infinity, right? What will it let that equal 0? The range, it's a square root, like that. 0 to infinity. So notice what happened here with the domains and the ranges. My domain was 0 to infinity. Down here, my range is 0 to infinity. My range was -8 to infinity. My domain is -8. And think about it. This is your x. Domain is x. Range is y. We end up just flip-flopping them. Right? That's how you find an inverse. You switch your x and y. So the domain and the range are important here. All right. Number 2. So this one's a little weird. Think about what the graph looks like. x minus 9. So we go to the right 9. So now which side do you want? So you also have an option. You could restrict the right side or the left side. So for instance, if I said g of x is x minus 9, which piece of the graph is that? That's this, because x minus 9 is going to go all the way down here. So x is x minus 9, where x has to be greater than or equal to 9. We also could do g of x is negative x plus 9, where x is less than or equal to 9. So you have an option of how you want to restrict it. The process for solving is the same. So let's see. So this is my domain is greater than 9. My range, domain. Sorry, I just go back and forth with these a lot. So y is greater than or equal to 0. Okay, so g minus 1 of x, if I solve that, is x plus 9. Yep. And then, so now the domain is going to be x is greater than or equal to 0. The range, y is greater than or equal to 9. Right? So they end up switching. All right, pause the video. Decide if the functions are inverses. So, f of g of x. Can you guess the answer? I hope you can. X squared plus 3 minus 3. X squared equals x. So the answer is no, absolute value of x, because g of x is not 1-to-1. You need to restrict the domain instead of u. I always do that. I always see that and think it's the eraser. It's the highlighter. The domain of g of x needs to be restricted. Okay. All right, number 4. What do you think about that one? All right, so I'm trying to think which one's easier. Doesn't actually matter. G of f of x, negative 2 times negative x over 2 minus 1 plus 1. So let's distribute, and I get x plus 2 plus 1, x plus 3. And this one is no, because g of f of x does not equal x. Does not equal the identity function. X is the identity function. All right, is g 1-to-1? If so, find its inverse. So let's check, is g a function? So we got 1, 3, 8, negative 3, negative 2. So all of those are different, so it is a function. And now let's check the range. 4, negative 5, 6, negative. So that's a no. No, because 3 and negative 3 both map to negative 5. How about number 6? Is this 1-to-1? So it is a function. All my x's are different. And it is 1-to-1 because all the y's are different. So this is a, oh no. So this is a yes. So the inverse, x, f minus 1 of x. So all we're going to do is flip-flop. 7, negative 3, negative 4 is 0, 8, 2, 0, negative 6. And that's it. One more page. All right, graph the inverse on the same set of axes. So now, does this have an inverse? It does. It's 1 to 1. It's a function and it's 1 to 1. So I'm going to write, I like to write down all these like corner points. So I got -8, 1, 2, 3, 4, 5. -8, -5. We've got -4, 4, 2, 6, and 3, 10. All right, so my inverse, so this is, let's call this f of x. And then I'm going to do it in red, f minus 1 of x is -5, -8, 4, -4, 6, 2, and 10, 3. -5, -8 here. 4, -4, 1, 2, 3, 4. I connect as I go. I keep the order because sometimes I've seen it where students, they don't connect as they go and then they end up connecting the wrong points. 6, 2, and 10, 3. All right, so look at this, and does anyone notice anything? There is a reflection here. What are you reflecting over? We are reflecting over the line y equals x. So if you draw that in, another way of thinking about inverse is it's a reflection over the line y equals x. Now think back into either geometry or middle school. I'd be impressed who remembers this. How do you reflect over the line y equals x? To reflect over the line y equals x, you switch your x and your y. xy becomes yx. So you're actually, think about, that's what you do when you find an inverse. So there is that connection to transformations. All right, and that is it. We are done with videos. Friday we'll just do some practice. And then next week we're going to have a quiz on inverse and composition. Have a fabulous day, guys.